Thank you so much for taking the time to speak with me today and do this interview. To reiterate, my name is Annie, and I created Sustainability Beyond the Lab to showcase sustainable innovations and make them more accessible, as well as the barriers that prevent their scale up. So, to start, could you introduce yourself and tell us a little bit about your research, especially at Stanford?
Yeah. Can you hear me okay? I think you cut out a little
Yeah.
bit at the end. Okay, yeah,
Uh,
yeah. So, my name is Henry Moise. It's really great to sit down and have this conversation with you. Um, I'm a PhD student at Stanford University studying chemical engineering, near the end of my PhD, actually. And yeah, our research, our lab looks at a bunch of different kinds of research, but one of the projects that we work on, which is the one that I work on, is this field called methane pyrolysis. So you take methane, which is CH4, and you heat it up to really high temperatures, or you use a catalyst and you decompose it into its elements, so into solid carbon and hydrogen. The reason why we do that is because the traditional way of making hydrogen is you take that CH4, the methane, and you react it with water, so it's H2O, and you produce CO or CO2 plus your hydrogen.
mhm.
And so pyrolysis is a way of making hydrogen without making CO2. So you want to make solid carbon instead of CO2. And hopefully that solid carbon can then find value in the market. So it can be used for batteries or it goes into tires, lots of different applications. Lots of cool stuff you can do with solid carbon, depending on the shape and morphology of it.
For audience that might not be that familiar with methane pyrolysis versus other types of hydrogen production, what makes methane pyrolysis better than more conventional methods?
Yeah, great question. It depends on what you mean by better. I think, everyone has a different idea of what better might look like. There's a cost argument to it, there's a emission standpoint to it, and there really is a balance between all of them. So there's an argument to be made from each stance. So I think the reason why most people are interested in it is from an emission standpoint.
Mhm.
So like I said, steam methane reforming, which is about I think it's about 95% of hydrogen in the US. We make our hydrogen from steam methane reforming, or SMR. You might hear me call it SMR throughout the interview. And then globally, I think it's about 75% of the world will produce hydrogen through SMR.
Mhm.
Um, and cost wise, it's really cheap. It's the cheapest way of making it, and that's why we do it. But in the process, you're making CO2. And when you think about emissions, there are two different kinds to think about. There's direct emissions, so it's like what's directly leaving your process or your reactor, and then there's indirect emissions, and that would be, you know, uh, the emission intensity of your feedstock, or the electricity you use on the site. Where is the electricity sourced from? So there's lots of different ways to quantify it, but the reason why people, are interested in pyrolysis is because theoretically you're not producing any direct emissions. So instead of producing CO2 or CO, you're producing solid carbon. And so that's a way of reducing emissions while using the same feedstock and producing the same products in the hope that you're going to leverage a lot of the same infrastructure that we already have to make a more green process.
Mhm.
Um, and then, you might hear some people, there's also the argument from a cost standpoint. There's some types of solid carbon where they're really high value.
Mhm.
So the value you generate from the carbon might be able to make the hydrogen cheaper than the hydrogen you'd make from SMR.
Mhm.
So again, caveats to everything I'm saying, but there's, a few different ways of looking at it. But I think most people approach it from the sustainability standpoint.
Mhm. Yeah, that's really interesting to hear about like the advantages it has over the conventional methods for hydrogen production. If
Mhm.
I can ask, to clarify, what makes hydrogen production so important for like the clean energy transition?
Yeah, no, great question. I should have probably started with that. Yeah, hydrogen is it's really interesting. It's a really difficult molecule to work with, but it's incredibly important. So the way that it's used today is mostly as a feedstock. So it's used in, ammonia, so fertilizer production for crops, which supports more than 50% of the global population. If you look at all the nitrogen that's in your body, more than 50% of that was generated from Haber-Bosch. So it's a pretty important reaction that it's a feedstock for. So without hydrogen, you couldn't do Haber-Bosch.
Yeah.
It's also used in refineries. So it's a way to desulfurize fuels or hydrocracking. It's a way of making fuels cleaner, more emission friendly, and enabling the sales of these fuels. Um, and then also, I think a third market for it that's really large is methanol production. So methanol itself is a big feedstock to a lot of other really important chemicals. And so, as a foundational material, it's really important, or a foundational molecule, not a material. And if you look at it, it's upstream of at least 2 to 3% of global GDP. So it's incredibly important. We're going to make it regardless of how carbon intensive it is or how cheap or expensive it is. We completely depend on it.
Mhm.
So that's why I think a lot of people are really interested. Well, is there a way to make it cleaner? Is there a way to make it cheaper? Those are always going to be something that people are going to be interested in.
Mhm.
So yeah, the those are the current uses for it. But a lot of people have renewed interest in, well, when you use hydrogen as a fuel,
Mhm.
it's very energy dense per mass. Per volume, that's a different question, but per mass it's very energy dense, and when you combust it or use it in a fuel cell, the byproduct is only water. And so from a clean fuel standpoint, it also has some interest in that regard.
Mhm. Yeah, that's really interesting hearing the different like uses for hydrogen, why it's so important. Are there
Mhm.
any specific projects that you're working on currently that are particularly innovative?
Well, if you ask every PhD student that, they'll all say yes. Yeah, I mean, I think there's a lot of cool research that's coming out of our lab and lots of other labs. So I think for anyone who's interested in chemical engineering or chemistry or processes in general, pyrolysis is a really interesting one to get into, where there's lots of academic research and there's a lot of really, I guess, feasible connections to industry. There's large attraction from industry to make this process work. Um, so yeah, my group, we look at a few different applications. Um, so pyrolysis, you can make different kinds of solid carbon depending on the catalyst you use, the temperatures, how you operate the reactor. And so, people might be familiar with graphite. That's probably the more
Yeah.
famous use of carbon. But there's lots of other things you can use it for. You can make carbon black, which is used in tires and textiles and inks. Um, and there's carbon nanotubes. That's kind of like a more niche field, but that's, certainly something that people look a lot at. They have these really phenomenal strength qualities, electrical qualities, thermal conductivities, a lot of really cool properties of CNTs. And so my group kind of has a few different projects in graphite as well as carbon nanotubes. And so we look at it from multiple standpoints. We want to make graphite for batteries or refractory materials. So even within nuclear, right? We wanted these graphite bricks to help, with being a refractory material, or batteries for, obviously, electric applications. So we want to try to make graphite from natural gas, which is mostly methane, because that's something that we have domestically a large quantity of here in the US. And so if we can make batteries from that natural gas, that would be a really interesting and economic way of approaching it.
Yeah.
We also make carbon nanotubes. Carbon nanotubes, you can add them to polymers, and they allow this, electronic, application for polymers. You can add it to cement and make cement stronger. There's lots of cool applications you can use for it. And the idea is that you want to try to maximize how many of these applications you can get into, because you want to have as much of a market
Mhm.
of solid carbon you can access, because that means you can sell more hydrogen and displace more of these SMRs.
Mhm. Yeah. What do you see as kind of the biggest barriers that prevent the scale up of the pyrolysis process? Is it mostly like economic incentives, like you discussed, or policy related, based on the scientific innovation itself, or kind of a combination of all of these factors?
Yeah, it's a really important question. And I think you got it right. It's, to be honest, it's all of them. It's a bit of everything. I think, policy has a major implication for how much technologies can mature and, find their way into the market. And then there's also, technical aspects to how well a technology matures. So for pyrolysis, for example, right, there's lots of technical limitations that make it challenging to scale. It's a really high temperature process. Um, and that's actually with the caveat, lots of people go about it differently. Some people use, microwave heating. Some people do plasma, so the project that we work on is thermal catalysis. So it's high temperatures and catalysis.
Mhm.
Every approach has their pros and cons technically. And so the big issue for the way we approach it is it's really high temperatures. It's really hard to have engineered materials that can sustain for long periods of time in these reactors and, produce economic quantities of carbon and hydrogen. So that would be an example of like a technical challenge. But let's say tomorrow we design the world's perfect catalyst. It has 100% methane conversion. It's super cheap. There's no issues there. It lasts forever in a reactor. Then beyond those technical limitations that we just solved, there's still these commercial limitations.
Mhm.
So the solid carbon market is really small compared to the hydrogen market. So when you do pyrolysis, you produce 3 times the amount of carbon than you do hydrogen by mass.
Mhm.
So let's say the US has to produce uh, 20 million tons of hydrogen annually. If
Mhm.
we want to make all the hydrogen in the US with natural gas, with methane pyrolysis, that means we'll be producing about 60 million tons of carbon, if I did my math correctly. And I actually don't know how much hydrogen we're making in the US right now. I'm just using that as an example.
Yeah.
But let's say you have to make 60 million tons of carbon. Finding a market for that carbon is really challenging because non-metallurgic markets, which would mean like markets that aren't coal. So
Mhm.
coal is used for like steel making and energy. If you're not going to utilize that market, which would be non-metallurgic markets, that market is, less than 10 million tons,
Mhm.
uh, probably globally. I would say less than 10 or 15 million tons globally. So you can see the challenge is like you have to find value for the carbon, but the carbon market's really small.
Yeah.
So that's why a lot of people are trying to create new markets for solid carbon. So that's why people want to add it to cement or try to replace, electric wires with carbon nanotubes. So there's lots of ways you can try to expand that market size. But that would be an example of like a non-technical limitation.
Mhm.
And then going beyond that, now let's say you solve both those problems. Maybe there's legislation that kind of gets in the way in policy, right? Natural gas, it has a warming effect to it, right? So maybe natural gas is not something we want to use as a feedstock in the
Yeah.
future. Um, Carbon nanotubes, right? They're these really small fibers. They're not super healthy to breathe in sometimes under certain applications. So maybe that's like a legislation thing that would come in and then make it difficult to sell that. So there's always multiple layers, and we need people working at every layer to help a technology mature,
Mhm.
right?
Yeah. That's really interesting hearing the different factors that come into play when trying to scale something like methane pyrolysis.
Yeah.
Yeah. Looking ahead, maybe 10 to 20 years in the future, are there any developments in hydrogen production that you're very excited about?
Yeah. Well, so within pyrolysis, I think there's lots of really cool companies and research groups working in that region. So I could talk a lot about that. I think people who are targeting making graphite, I think it's a really cool application since in the US domestically we're not making a whole lot of graphite. And
Mhm.
if we find a way to make graphite from natural gas, that would be a really cool innovation. It would help a lot of people. I think people who are interested in making carbon nanotubes, I think there's lots of opportunities when you think about, CNT enhanced polymers or cement mixtures, right? There's lots of really cool mechanical properties you can get from that.
Mhm.
And of course, when I'm talking about, these carbons, I'm of course talking about you're able to sell the hydrogen. So those would be the cool applications within methane pyrolysis. I would also, it's a much more niche and early stage field of study, but there's also this new way of looking at hydrogen from a geologic standpoint.
Yeah.
There is geologic hydrogen, or sometimes called natural hydrogen, or sometimes called gold or white hydrogen, right? Because hydrogen has all those colors. It's super early, but it's actually a really cool idea if it were to work because you can extract it the same way you would extract natural gas.
Mhm.
And so because of that, you don't have all these expensive reactors and processes to convert natural gas to hydrogen. You might be able to just extract hydrogen as is. So that would be the best of both worlds. if you could make the technology make sense, because it would be cheaper than SMR and it would be cleaner than SMR and pyrolysis. So that would be like that would really be the unicorn of things to work on. So anyone who's thinking about doing graduate school in chemical engineering, see if departments have research in that area. I think it would be a really worthwhile project to look at.
Mhm. Yeah, I remember you mentioning that in our previous conversation. That's really
Yeah.
interesting. Before we wrap up, is there anything during the interview that we didn't get a chance to discuss, that you think the public should know about sustainability broadly or specifically hydrogen production?
Yeah, I mean, sustainability in general, like I think what I feel like I've seen, like what we talked about in the sense where, there's multiple layers to making a technology mature and making it make sense.
Hmm.
Sustainability is important. It's, we all agree that, too much CO2 is being produced and we want to try to make processes that produce less of it. But at the end of the day, a process has to be economic for it to scale.
Hmm.
It's like saying you want to end world hunger. We all want to end world hunger. It has to come from somewhere. Someone has to pay for it,
Yeah.
right? And I totally believe it's within our power to make processes that are more sustainable or end world hunger, whatever it is. But you have to make sure that it has to be done within the existing frame.
Hmm.
So I mean that in the sense where you have to make something cost competitive. Sustainability is the desired outcome, but it can't be the driving force. The economic viability of your process has to be the driving force. So for anyone who wants to get into sustainability and try to make that big impact, you have to approach it first from cost with the mindset of, okay, but it cost after cost, then it's sustainability.
Hmm.
Ideally, those two are coming together, but the first one has to be cost.
Yeah, that's really interesting hearing both your research and your perspective on scaling these technologies. And thank you again for doing this interview with me.
Yeah, of course. Thanks for having me, and I really appreciated having the conversation.
Yeah.
Happy to chat any other time.